All right, lesson 1-7, day 2. We're looking at the intersections of linear and quadratic equations. So can fall into one of three categories. There can be 2 points of intersection between a line and a quadratic, 1 point of intersection, or no points of intersection. And let's just talk about this real quickly. This point of intersection would be known as the point of tangency. Okay, the line would be tangent to the quadratic if it only intersects the quadratic one time. And that might not make a whole lot of sense right now, but that's the basis of calculus. All right, find the intersection of the given quadratic and linear. So notice they're both set equal for y. Now I can't solve it like a system, but I can solve it like a system in that I'm going to use substitution. What I meant was I can't use elimination like we do with the system of equations. Okay, so 4 minus 2x equals x squared minus 6x plus 8. Now it's like the problem on our quiz and our homeworks. Got to get the equation set equal to 0. Adding 2x combines to negative 4x. Subtracting 4, I get plus 4. This is a perfect square trinomial. So this factors to x minus 2 quantity squared. So x equals 2 would be my only point of intersection. Now going back, we have to find the corresponding y value. Does not matter which function you plug it into. But the linear is generally easier. All right, so my y coordinate is 0. So the point of intersection is 2, 0. So this would be an example of this line, 4 minus 2x, would be tangent to the graph of the quadratic, since it only has 1 point of intersection. All right, so I'm going to take this and solve for y. So I get y equals negative x minus 6. Setting that equal to the quadratic, moving everything over, x squared plus 7x plus 6. Okay, this is factorable, so it factors into x plus 6 times x plus 1. So I get x is equal to negative 6 and x is equal to negative 1. So what I would like you to please do, find the corresponding y values. So if x is negative 6, what's the y coordinate? And when x is equal to negative 1, what's that y coordinate? Sorry about that. Okay, then lastly, you need to be able to determine quadratic equations from a set of given information. So recall the 3 forms that we studied. Standard form, ax squared plus bx plus c. Vertex form, y equals a times x minus h quantity squared plus k. And our factored form, a times x minus m times x minus n. So I'm just going to add here. Recall to find the vertex, that's that simple expression. Your x coordinate is negative b over 2a. And then our y coordinate, we plug that value back in. Okay. In factored form, so the vertex of a quadratic, the x coordinate is the average of the x-intercepts. So let's think about this. If you have, let's say I have x-intercepts at 1 and 5. Well, we know that every quadratic has to have a line of symmetry. So where's the line of symmetry going to happen there? It's going to happen at the halfway point. And the halfway would be the average of whatever those x-intercepts are. So this doesn't give us the y coordinate, but where do we get the y coordinate? We just plug that back into the original. Okay, so this piece of information is going to be important if we know the intercepts and we need to determine the vertex. All right, so let's do 2 examples together. Find the equation of the parabola with zeros at 5 and 3 and a minimum value of -3. So my zeros are my x-intercepts. So we know that the x-intercepts are +5 and +3. Well, your x-intercepts are directly related to what your factors are. Okay, so if my intercepts are +5 and +3, my factored form would be x minus 5 times x minus 3. Okay, so thinking about the 3 forms we have, it sets itself up nicely for us to write this quadratic in factored form. Now the only deal is we need to determine what the value of A is. Okay, so our vertex, remember that your vertex is either your maximum or your minimum value. You're told here that it's a minimum. Minimum. If your vertex is a minimum, then you know your parabola is going to open up. So that tells me that my value of A, when we find it, it better be positive. The value itself is the y coordinate. So on our vertex, we already know that the y value is -3. So it's up to us to determine what the x coordinate is, because we need that in order to plug it into the equation to find that value of A. This is where this piece of information becomes important. Okay, I have the factors. I need the x coordinate of my vertex. So the x coordinate of our vertex comes from the average of the intercepts. Okay, so my x coordinate here is +4. Now look what I have. I have an equation. I need to find A, and now I have a point on the graph of the quadratic. So I'm going to plug that in. So -3 equals A times 4 minus 5 times 4 minus 3. Okay, so I get -3 is equal to A times -1 times +1. So A, I get to be +3. Okay, that corresponds to the fact that my vertex is a minimum. And now putting everything together, our final answer would be y is equal to 3 times x minus 5 times x minus 3. Now, we went through the trouble to find the vertex, so I could just as easily write the equation in vertex form. Y equals A, x minus the x coordinate of the vertex, quantity squared, plus k. Okay, and then either of these we could expand to write in standard form, but you just pick the one that you think is fit for the given information and then go from there. All right, last example. Find the equation of a parabola with a vertex at 2, 3, and it passes through the point 1, 1. So this really sets itself up nicely. Y equals A, x minus the x coordinate, quantity squared, plus the y coordinate. All right, this one's even easier than the last because now we are already given the coordinates of a point on the graph of the function. So I'm just going to plug that information in. 1 equals A, 1 minus 2 squared plus 3. 1 minus 2 is -1. Squared just gives me +1. So then I have a plus 3. Subtracting 3 from both sides, I get -2 for A. So my final answer, I put all the information together. Now from here, if you were asked to graph, we have the vertex, and then you know that the parabola is going to open down because A is -1. Okay, that's it for day 2.